past few decades, there have been multiple debates about human existence on Earth. Most of these debates point to the fact that there were several past civilizations on our planet. Even before modern human society began to thrive. With the help of archaeologists, scientists have finally discovered a rare piece of evidence that will put an end to this debate. Was Earth once inhabited by advanced civilizations? If so, what role did they play in our evolution and advancement as humans? Join us as we explore how there was an advanced civilization before humans. Since the Earth was created over 4 billion years ago, scientists, historians, and archaeologists have noted and dated events that took place on our planet. Right from the time of the Mesopotamians to the Greeks, the Romans, the Persians, and many other cultures that thrived. Some of these ancient cultures lasted for at least 1,000 years, with notable civilizations like ancient Egypt thriving for over 3,000 years, which is also known as 30 dynasties according to the ancient Egyptian calendar. Despite the magnificent structures and evidence that can be seen from ancient Egypt, there are still theories from scientists saying that they're not the first advanced civilization to grace our planet's surface. We can't say for sure because Earth's surface is mostly fresh in geologic terms. Reasons due to weathering, wind, water, freezing, and thawing take their toll on the planet, as well as longer-term changes caused by volcanic activity and sliding crustal plates known as tectonic activity, or Earth's tectonic plates, which fold today's ground into tomorrow's interior. And the progressive makeover of the planet is majorly the fastest in the mountains, which happen slower in the tectonically inactive deserts. But as scientists continued to research and study to find the world's oldest surface, they came across an ancient desert pavement in Israel's Negev desert. The area was inspected and a region was seen to date as far back as 1.8 million years, according to Ari Matmon and colleagues at the Hebrew University of Jerusalem. This region in the Negev desert is the oldest known vast expanse of surface area. The discovered site is more than 4 times more senior than the confirmed next most aged desert pavement in Nevada, based on the details on the website of the American Association for the Advancement of Science. The dating was done by examining concentrations of a particular isotope called 10Be, which is produced only at the surface, showing how long a specific thing has been exposed. But that still does not prove the fact that there was an advanced civilization before us humans. Scientists and researchers have been used to thinking about extinct civilizations when it comes to underwater statues and subterranean ruins of ancient civilizations. But these types of artifacts can only be of ultimate value if you're interested in researching on a time scale of a few thousand years. But once you roll the clock back to tens of millions or hundreds of millions of years, things get more scattered. Dating back to tens and hundreds of millions of years is complicated because the geologic record doesn't go past what scientists and researchers call the Quaternary period, which dates from about 2.6 million years ago. If scientists want to research further than the Quaternary, basically everything by then has been turned over and crushed to dust. Going as far back as the past, the Quaternary period also means that we are not talking about human civilizations anymore because humans did not begin to appear on Earth until about 300,000 years ago or thereabout. Every form of life form that possibly existed on Earth is basically about other species, and for that reason is where the Silurian hypothesis comes into play. The Silurian hypothesis is a reference to an ancient civilization of advanced reptiles, which featured in the British science fiction show Doctor Who. Scientists at NASA's Goddard Institute for Space Studies and the University of Rochester observed the scientific evidence deeply that our race is the only advanced civilization ever to have existed on our planet. Still, a professor of physics and astronomy at Rochester and a co-author of the Silurian hypothesis, Adam Frank, asked if we are truly the first technological species on Earth. This question was asked because human civilization has had an industrial society for only about 300 years, but there's been complex life on land for nearly 400 million years. So let's imagine if a hail of asteroids happens today and makes humans extinct. Any future civilization that might arise on Earth after millions of years might find it hard to recognize traces of human society. In the same vein, if an ancient civilization existed on the planet millions of years ago, we might have a hard time discovering it. However, scientists and researchers on Earth never give up until a clue is found. So would they be able to discover clear traces of an ancient and advanced species that built a relatively short-lived industrial civilization long before our own? Maybe, for example, some early animals rose briefly to society during the Paleocene epoch, which lasted from about 66 to 56 million years ago. There are fossils to prove this era, of course, but the sector of life that gets fossilized is always tiny and varies depending on time and habitat. As a result, it would be easy to miss such an industrial civilization even if it spanned 100,000 years, and that would be a number that's 500 times longer than the existence of our industrial civilization so far. This is why scientists and researchers theorize that the discovery of physical artifacts would certainly be the most dramatic evidence of a Silurian-style civilization on Earth, even though many scientists doubt anything of the sort will ever be discovered. There are considerable disputes in discovering evidence of a Silurian-style civilization on Earth because presently the cities in human civilizations cover less than 1% of the Earth's surface, and any comparable cities from an earlier civilization would be easy for modern-day paleontologists to miss. So since all direct evidence would be far gone after hundreds of millions of years, what kind of evidence might then still remain to prove another civilization once existed? Scientists and researchers postulated that finding fossilized bones would be an incredible option. Still, if another advanced civilization graced Earth's surface, that is, if they walked, it would also be easy to miss their fossilized skeletons if they had one. Modern humans have just been around and thriving for barely 100,000 years, a thin sliver of time within the vast and spotty fossil record. Based on these reasons, Frank and Gavin Schmidt, a climatologist at Goddard and a co-author of the Silurian hypothesis, moves to examine the possibility of finding chemical relics of an ancient terrestrial civilization that once graced our planet. These evaluations were carried out with the help of human technology as their guide. Both co-authors on the Silurian hypothesis, Schmidt and Frank, suggested zeroing in on plastics and other synthetic molecules that have survived long enough. Also, radioactive fallout was a part of the context in case parts of ancient lizard people had taken part in some atomic warfare. In the case of humans, technological development has evolved alongside widespread extinctions and rapid environmental changes, so those are looming problems as well. These scientists, however, kept searching for ways around this. After checking many suspiciously abrupt geologic events dating over the past 380 million years, the team conducting the hypothesis concluded that none of them clearly aligned with a technological profile. Regardless of these results, one of the scientists, Frank Adams, is proposing more research, such as examining how modern industrial chemicals still remain in ocean sediments, and then checking to see if traces of similar chemicals in the geologic record can be found. Frank proposes that an intense knowledge about the human environmental footprint will also have practical consequences. It would help us devise better ways to achieve a long-term balance with the planet so we don't end up as tomorrow's forgotten species. But if we assume human civilization collapses at our current stage of development, what traces of our existence are we going to leave behind? Well, that should not be a complex feat, as our human industrial civilization has gone completely global. As a result, humans' collective activity is creating a couple of traces that will be found by researchers and scientists 100 million years into the future. Let's take an example of our civilization's extensive use of fertilizer. Fertilizer keeps 7 billion people fed, but it also means we're changing the course of the planet's flows of nitrogen into food production. With this extensive use, scientists and researchers could see this in attributes of nitrogen showing up in sediments from our era. Also, our relentless hunger for the rare earth elements used in electronic gizmos. Far more of these atoms are now wandering around the planet's surface than they're supposed to, and they might also show up in future sediments too. Even our creation and use of synthetic steroids has now become so widespread that it too may be detectable in geologic strata in less than 10 million years from now. Also, let's not forget all that plastic scattered across the planet. Studies carried out by scientists and researchers have shown that increasing amounts of plastic marine litter are being deposited on the sea floor everywhere, from the deep basins to the coastal areas and even the Arctic. And factors that play specific roles on our planet, such as the sun, waves, and wind, grind down large-scale plastic artifacts and therefore leave the seas with microscopic particles of plastic that will eventually rain down on the ocean floor. Once on the ocean floor, it could create a layer that could stay relevant for geological timescales. But despite the possibility of these traces remaining for future scientists and researchers to find traces of our civilization, the big question that remains to stand as a debate is how long any of these traces of our society will last long enough to be detected. In the Silurian hypothesis study, the researchers found that each trace tended to make it into future sediments, and one thing that is widely thought to stand the test of time could be Mount Rushmore. It could be that these future scientists would find these weathered faces sculpted onto a mountain and might regard them as gods our civilization once worshipped. And yet, ironically, the most promising marker of humanity's presence as an advanced civilization is a byproduct of one activity that may threaten it the most. When fossil fuels burn, our civilization releases carbon into the atmosphere that was once part of living tissues. The ancient carbon is consumed in one of that element's 3 naturally occurring varieties or isotopes. For this reason, it makes us understand that the more fossil fuels our civilizations burn, the more the balance of these carbon isotopes shifts. These carbon isotope shifts are known as the Seuss effect by atmospheric scientists. The change in isotopic ratios of carbon due to fossil fuel use has been quite noticeable over the past decades and centuries. Temperature increases also leave traces of isotopic signals. These shifts should be clear enough and noticeable to any future scientist or researcher who chemically analyzes exposed rock layers from our era. Along with these spikes, this Anthropocene layer might also hold brief limits in plastic nanoparticles, nitrogen, and even synthetic steroids. So if this stands as the proof that our civilization will leave behind things for future scientists and researchers, would the same signals exist right now in rocks, just waiting to tell us of civilizations long gone? That would be a valid theory, though, because as researchers found, Earth passed through a process called the Paleocene-Eocene thermal maximum 56 million years ago. During the Paleocene-Eocene thermal maximum, the planet's average temperature was as high as 15 degrees Fahrenheit above what we encounter today. At that point in time, it was a world that existed almost without ice, as classic summer temperatures at the poles reached close to a calm 70 degrees Fahrenheit. Judging the isotopic record from the Paleocene-Eocene thermal maximum, scientists detected oxygen and carbon isotope ratios penetrating precisely the way we expect to see in the Anthropocene record. There are also other incidents like the Paleocene-Eocene thermal maximum in the history of our planet which show evidence like our hypothetical Anthropocene signal. They comprise an event that took place a few million years after the PETM, dubbed the Eocene layers of mysterious origin, and notable events in the Cretaceous that left the ocean without oxygen for many millennia or even longer than suggested. But are these events signs of previous non-human industrial civilizations? We don't think so, but we can't be too sure. While there are traces that the Paleocene-Eocene thermal maximum could have been influenced by an intense release of buried fossil carbon into the air, it's the timescale of these significant changes. The Paleocene-Eocene thermal maximum isotope spikes fall and rise over the course of a few 100,000 years. But what makes the Anthropocene so exceptional in terms of Earth's history is the speed at which we're discarding fossil carbon into our planet's atmosphere. There have also been geological times when Earth's carbon dioxide has been as high or higher than it is in our present day, but never before in the planet's history of over 4 billion years has so much buried carbon been dumped back into the atmosphere so quickly. So the isotopic spikes we observe in the geologic record may not be spiky enough to fit the Silurian hypothesis bill as we think it would. However, there seems to be a problem here. If an earlier species' industrial activity does not survive long enough, the possibility of our researchers finding it easily would be difficult. The Paleocene-Eocene thermal maximum spikes majorly explain to us Earth's timescales for responding to whatever triggered it, not compulsorily the timescale of the cause. So it might take both dedicated and novel detection methods to detect traces of an actual short-lived event in ancient sediments. To put it more simply, if you're not categorically searching for it, you might not find it. Basically, this was the most concrete conclusion of the Silurian hypothesis study. The Silurian hypothesis study was not easy for either author Adam Frank and Gavin Schmidt, as you don't see researchers write a paper suggesting a hypothesis they don't support. As a matter of fact, Adam and Gavin do not believe that the Earth once hosted a 50-million-year-old Paleocene civilization. But when asked if they could notice genuinely ancient industrial societies, the authors of this study were forced to ask about the generic kinds of impacts any civilization might have on a planet. That's basically what the astrobiological point of view on climate change is all about. When the culture reaches truly planetary scales, some reactions must be on the coupled planetary systems that gave it life: air, water, and rock. This will be particularly true for young civilizations like the human race, which is still advancing in technological capacity. There are, in other words, no free handouts. While some energy sources will have lower effects, for example, solar versus fossil fuels, it's impossible to power a global civilization without some amount of impact affecting the planet. When one realizes that through climate change the necessity to find lower impact energy sources, the less impact you will leave. Therefore, the more sustainable your civilization becomes, the tinier the signal you'll leave for future civilizations to detect. Another thing this study added to the theory of an advanced civilization existing before humans is that their research created the hypothetical possibility that some planets might possess fossil fuel-driven cycles of civilization development and collapse. Suppose a particular society utilizes fossil fuels in its endeavors or activities. In that case, they can trigger climate change, leading to a massive decrease in ocean oxygen levels. The low oxygen levels, also known as ocean anoxia, assist in setting off the required conditions needed for making fossil fuels like oil and coal in the first instance. With this effort, a civilization and its demise might grow the seed for new societies in the future to come. But when we inquire about civilizations lost in deep time, we're also asking about the possibility of universal rules guiding the evolution of all biospheres in all their creative potential, including the birth of all civilizations. Even without pickup driving Paleocenians, we're only now seeing how rich the potential might be. Despite the point of view from Adam Frank and Gavin Schmidt, Frank is a curious person interested in investigating more out-of-the-ordinary ideas in the course of finding Silurian-style signatures. You could try looking on the moon, he said. And inspecting the moon is one of the goals and a selected target of Penn State University astronomer Jason Wright and a couple of other researchers who are now applying complex scientific thinking and coming up with theories to the possibility of pre-human technological civilizations. Habitable planets like Earth are pretty good at tearing down unmaintained things on their surfaces, Wright says. Based on this statement, he's been nurturing the thought that such an advanced civilization that once lived on our planet might have been one that traveled out into space. If they had been spacefaring civilizations, evidence of their technology used during their time or technosignatures could be discovered elsewhere in the solar system. However, Wright also suggests that searching for such artifacts is not limited to just the lunar surface. The surface of planets like Mars and asteroids can also be inspected. Other places where such objects could theoretically thrive for hundreds of millions or even billions of years and can still be detected by future generations should be checked. SpaceX's launch of a Tesla Roadster into space gives an idea about how such a search might go. Several astronomers point their telescopes at the space car. They showed that even if you had no idea what you were looking at, one would still single it out almost immediately as one weird-looking asteroid. Discovering technosignatures in space can be regarded as a painstaking mission, but Wright proposes that the effort would yield results. There are many other reasons to find peculiar structures on Mars and the Moon and to look for weird asteroids, he says. Such findings might reveal new details about the evolutions and history of the solar system, or about resources that might be useful to future space travelers. If the mission brings about the discovery of a giant black obelisk somewhere, so much the better. And apart from Jason Wright, other people strongly believe that long before ancient Egypt, Babylonia, and Mesopotamia existed, an advanced civilization thrived earlier in humanity's history. One such person is autodidact named Graham Hancock. Hancock strongly believes that a glorious civilization existed, one that was wiped out by a comet or asteroid strike around 12,000 years ago. Most evidence of the civilization's existence vanished, leaving only the slightest traces about the extinct culture. One of such traces is what Hancock thinks is a cryptic warning that such a celestial catastrophe could also happen to our civilization. But no matter how bad an extraterrestrial impact might be, scientists and researchers will assume that after centuries of flourishing, every last tool, structure, clothing, and presumably from an advanced civilization, writing, and other forms of technology all disappeared from the Earth's surface. Hancock's impact hypothesis comes from scientists who first suggested it in 2007 as an explanation for the North American megafaunal extinction that happened during that period and has been the subject of vigorous scientific debate. However, it has not gone well. In support of the lack of any impact craters determined to have occurred around that time anywhere in the world, the radiocarbon dates of the layer of carbon, charcoal, soot, microspherules, iridium, and nanodiamonds, which is said to have been the outcome of this disastrous event, vary widely before and after the megafaunal extinction, anywhere from 14,000 to 10,000 years ago. Also, although 37 mammal genera went extinct in North America while most other species survived and flourished, 52 mammal genera went extinct in South America simultaneously, supposedly not due to the impact. These extinctions happened with human arrival, giving more points to the more widely accepted overhunting hypothesis. Hancock also bases his cases mainly on the argument of ignorance. His reasons are based on the "scientists cannot explain X, then Y is a legitimate theory," or the argument from personal disbelief because I cannot explain X, then my Y theory is valid. Creationists employ this kind of reasoning, but in Hancock's case, the gods are the magicians of civilization to us. This reasoning causes two problems. One, scientists do have good explanations for Hancock's X's. For example, the Great Sphinx and the pyramids, even if they are not in total accord. Two, eventually one's theory must rest on positive proof in favor of it, not just negative evidence against accepted theories. Hancock's biggest X is Göbekli Tepe in Turkey, with its T-shaped megalithic 7 to 10-ton stone pillars cut and towed from limestone quarries. It dates as far back as 11,000 years ago, when humans lived as hunter-gatherers without, presumably, the skills and labor to produce them. For that reason, Hancock concludes at the bare minimum it would mean that some as yet unknown and unidentified people somewhere in the world had already mastered all the arts and attributes of a high civilization more than 12,000 years ago in the depths of the last ice age, and had sent out emissaries around the world to spread the benefits of their knowledge. This sounds appealing, but it's the discrimination of low expectations. Who is to say what hunter-gatherers are or are not capable of doing? Also, Göbekli Tepe was a ceremonial religious site, not a city. There is no evidence that it was used as a habitat. In fact, there are no traces of metal tools, no domesticated animal bones, no inscriptions or writing, or any products invented by other advanced civilizations. Lastly, Hancock has spent several years on his mission to discover the gurus that brought civilization. Yet despite these decades of searching, he has failed to produce enough evidence to show scientists that the standard timeline of human history needs significant changing. Hancock alleges that mainstream science is hooked on a uniformitarian model of slow, gradual change and cannot accept a catastrophic clarification. But that is not true. From the Big Bang to the immense collision to the origin of meteor strikes to the asteroid impact that killed the dinosaurs to the numerous sudden downfalls of civilizations documented by Jared Diamond in his 2005 book Collapse, catastrophism is alive and doing well in mainstream science. The real magicians are the scientists who have worked this all out. What do you think about Hancock's theory? Do you support it? Let us know your thoughts in the comments section below.